The case study we'll be looking at today is an organic synthesis process between two materials, A and B, of varying quality, as well as a solvent. Now, the challenge is we only can use the fine powder to produce the tablets and continue to the next step in the process. We store that data along with the actual outcomes that we observed historically, so whether a batch was good or bad. We process that data and import it inside Knowledge Studio, where we develop the machine learning model and evaluate the performance of that model. Once we're happy with the model, we export the model in form of code, whether it's R code or Python code, and import it inside Panopticon to deploy the model. Here we have the workflow in Knowledge Studio. We have the modeling data that was used to build the decision tree model that I've shown you earlier, as well as evaluation data that we use to test the performance of the model on a holdout sample that the model hasn't seen before. In addition to the ROC chart, there are many other metrics that we can use to evaluate the performance of the model, such as the lift chart and the KS chart. Once we're happy with the performance of our model, it's not enough to just leave it inside Knowledge Studio. We need to be able to export it out to Panopticon in order to deploy it. So here I've created both R code as an example, as well as Python code that can be deployed within Panopticon. I will now hand it over to my colleague Ludwig that will take us through the process of deploying and monitoring the model within Panopticon.
Let's go to the Panopticon visualization server and open up the Altair Smart Factory workbook. In the first dashboard, we have a monitoring focus. The display emphasizes detail about what is happening right now in this moment. In real life, the physical production process runs for 700 minutes, with sensors collecting data about the process once every minute. For this presentation, we're running the process at an elevated speed, where 4 minutes of sample data is pushed through every second. We can observe the latest measurements as collected by sensors for each step in the process. This gives clear information about the current status. Moving to the time series analysis dashboard, here we can clearly see the benefits of using time series visualization. Not only can we understand what is happening right now, but we can also observe the historic behavior leading up to the current state. We're getting continuous feedback from our outcome prediction scoring model, which is applied to all of the process sensor data collected so far. This quickly gives us a prediction of the outcome as being good, with when the percentage of fine grain is greater than 90%, or bad if the percentage is less than 90%. Running at 240 times the original rate, we're actually scoring this data 4 times per second, which can be observed in this value. The tables on the lower right show information about the latest measurements as collected by the sensors, and also about totals and averages collected so far into the process. The time series visualizations share a common time scale, so that when the process moves from one stage to the next, it clearly shows in the graphs. Let's move to the final dashboard to see an example of what-if scenarios. Let's start a new simulation. By having data from previous process batches stored, we can investigate how different input parameters would have affected the outcome of a process batch. This allows us to evaluate options at low cost without running a physical process batch. For example, with input parameters set with such as solvent amount set to high and reactor temperature set to normal, we'll see that the predicted outcome is initially good, with a probability of just under 77%. As soon as the average reactor temperature reaches 83 degrees, we will see that the probability further increases to 97%. On the other hand, if we set solvent amount to low, we can see that the outcome is predicted to be bad with a probability of 61%. If we try and counteract that by boosting reactor temperature to 110%, we can see that the outcome prediction changes from bad to good shortly after 50 process minutes. Still, the probability of this good outcome is lower than what we saw with the default values previously.